Hello everyone, welcome to Explore Hub. For this example, we're told to evaluate the limit below, which is the limit as x approaches 1 in the function x minus 1 squared times sine of 1 over x minus 1 plus 1. Notice that it is very difficult to evaluate this limit using direct substitution, since the expression 1 over x minus 1 is not defined for x equals 1. But we can use the squeeze theorem to evaluate this limit. And in order to use this theorem, we need to find an upper and lower bound for this function. We know that the function sine of 1 over x minus 1 is greater or equal to negative 1, but less than or equal to 1. So sine of 1 over x minus 1 is greater or equal to negative 1 and less than or equal to 1, which means that negative x minus 1 squared is less than or equal to x minus 1 squared times sine of 1 over x minus 1, which is less than or equal to x minus 1 squared, since x minus 1 squared is non-negative. And this means that negative x minus 1 squared plus 1 is less than or equal to x minus 1 squared times sine of 1 over x minus 1 plus 1, which is less than or equal to x minus 1 squared plus 1. And now we found an upper and lower bound for the function. So the next step would be to find the limit as x approaches 1 in the functions negative x minus 1 squared plus 1 and x minus 1 squared plus 1. So the limit as x approaches 1 in the function negative x minus 1 squared plus 1 is equal to negative 0 squared plus 1, which is equal to 1. And likewise, the limit as x approaches 1 in the function x minus 1 squared plus 1 is equal to 0 squared plus 1, which is equal to 1. And since the limits of the upper and lower bounds are equal to 1 as x approaches 1, then by the squeeze theorem, this means that the limit as x approaches 1 in the function x minus 1 squared times sine of 1 over x minus 1 plus 1 is equal to 1. And that's it for this example. Thank you for joining us. See you in the next lesson.